Hi everyone, welcome to this new episode where we will explore model-driven network automation with no Jinja, full IDE support, code completions, auto-suggestions, neatly IDE integration for your models, all of that good stuff that we love, but without Yang. That sounds a bit like a dream come true and a clickbaiting title, but that is exactly what we're going to do today when using EDA APIs. Now, the history behind this video kind of rooted in the interesting discussions that we had a couple of days back at Network Automation Forum Slack channel, where a lot of people voiced their opinions that, the Yang tooling is prohibiting us from moving forward with model-driven network automation. People would love to use the programmable bindings, language bindings, and create those interfaces, VLANs, those service constructs by just using the native code constructs for their favorite language, but the tooling does not allow them to do that. Sometimes it's just like the lack of tooling for a specific language, or maybe the tool existed, but it does not offer the feature set that is required, or sometimes the tool has been active but is now abandoned. And you can probably find in your memory an example of such a tool, but these kind of problems, they do exist. And that is also one of the reasons that if you look at the Network Automation Forum presenters and the talks that are being given, most of them, I would not say all, but a lot of them approach the network automation from the CLI screen scraping kind of angle. And Yang is one of the reasons why people still use screen scraping and do not have this luxury of working with fully modeled network operating system and fully modeled and generated code bindings. Yang is one of these problems, but it's not the only one, of course. And we will not be able to cover all of them. Today, we will focus on the on the model-driven network automation when Yang is not involved. And I will show you that this is possible, and this might be a very compelling way for you to start thinking about how you would want to automate your networks when keeping in mind that the tooling for Yang is not there, and we cannot create this tooling ecosystem in a day, right? That is also clear. So, okay, we will talk about the Nokia EDA platform that we recently announced and the way it works and how it kind of delivers on the promises that I started this video with. Now, if you look at this diagram, you will see that EDA sits between the API client being your script, your program, or maybe just your curl command line tool or Postman, and the network nodes that EDA manages. And you can see that there are two different interfaces and protocols that we use. For EDA to manage the nodes, our SRO Linuxes and SRS nodes, EDA still uses GNMI, and Yang is there. Yang is kind of not going anywhere anytime soon. The modeling language for network operating systems for most of the vendors is Yang. So Yang is with us to stay. So EDA still uses the GNMI and Yang to kind of configure the boxes. But the sweet sauce in how we translate the user intent to those GNMI commands. And what we will see in this example in a couple of minutes is how you can use your traditional software engineering techniques and commands to generate those intents and configurations that EDA will push to the nodes. At the same time, you will not see a single line of Yang. We will work with OpenAPI and REST interface that EDA exposes northbound. So if you haven't heard about EDA, I do recommend go to docs.eda.dev and check out the videos done by Bruce Wallace. They give you a neat and a kind of concise introduction to the platform and the ideas that we've encompassed in it. But one of the ideas that is important for this particular talk is that we created EDA as a declarative and abstraction-based platform. That means that if you want to create an interface on your node, you create an interface resource in the EDA cluster, in the EDA system, and then EDA will make sure that whatever nodes it needs to touch, it will do that, and it will make sure that the transaction has been completed, there were no validation errors, and the resource has been created. Your intent is now in place. So we will have to create those intents with you today, but we will do this programmatically and with fully modeled approach. Now, how do you create something in EDA? Well, of course, you have a UI that is available with a platform, but this is not something that we will use. We will use Python today and REST API to interface with EDA API server. And we will start with a basic and simple idea of how do I create an interface on my system, on my Linux switches in this particular case, using EDA and fully modeled approach. So to think about this problem, you have to realize that you need to create an interface resource in the system. How to create an interface resource if you do not have a UI that shows you the form and the fields that you need to fill in? Well, you need to consume the API documentation. Since EDA is Kubernetes-based and adopts the Kubernetes resource model principles, you will find a lot of similarities with how resources are created in Kubernetes. So our APIs that we expose northbound are modeled with OpenAPI v3 schema, a popular language for defining REST APIs. You will find these API schemas for a million of software projects that you interface with, like your cloud APIs, your Heroku APIs, whatever system that exposes a REST API usually comes with an OpenAPI schema that you can use to generate clients and to generate the models. So how do we create an interface in system like EDA? We need to find the OpenAPI schema for the interface. Now, we are now greasing the gears to open source the applications that will come shipped with EDA. But before we do that, I created this work in progress repository that contains all the OpenAPI specifications for the applications that are shipped with EDA version 24.12. And if you look at this list, this is EDA Labs/OpenAPI on GitHub, you will find a lot of applications, as we call them. And the applications contain the OpenAPI schema as well. So if you look close here, you will find the interfaces API reference. If I click here, you'll recognize the familiar Swagger UI interface. That is exactly how you can consume the API model for the interfaces application. And the interfaces application allows you to create interfaces on a system. If you scroll down, and if you are familiar with OpenAPI and Swagger UI, you know that at the bottom of the page, you have the schemas. And the schemas are the models that the API uses to model the objects that API works with. So if you go a little bit down, you will find an interface model that I'm showing right now. And opening this up, you will see the specification for the interface custom resource that you can create in EDA to create an interface on a node. If you are familiar with Kubernetes resource model, you will recognize it's mapped one-to-one to the same KRM model. You have the API version where you specify which version of the API you are going to use. This is the kind of the resource that you are creating. Then you have the metadata where usually you have your namespace and names. And then you have the spec, the specification of the resource. Now, if I open this up, you will see that specification contains a lot of stuff that is resembling an interface, right? You can set the description of the interface, the enablement status, the Ethernet configuration, is it a lag or not, and you can specify the members of this interface. Now, this might look a bit familiar if you have worked with Kubernetes. If not, this is just a model, one of the ways how you can model an interface resource in an abstract form, right? There is nothing that says this is an Linux resource or SRS resource. This is a generic resource. And remember, EDA uses the abstractions quite a lot, and we try to create abstracted interfaces so that the node-specific implementation do not leak into those abstracted interfaces or resources that we create in the system. So now that we know that we can create an interface using a resource like V1 Alpha interface, the question comes, how do you actually create this? Well, in EDA, you have different interfaces to the system. As I mentioned, there is a UI, there is the OpenAPI REST interface that we are going to use, and there's also a Kubernetes interface that you can use kubectl to create your resources on the system. Now, since this is the automation and network automation specifically topic, we will use the REST API and OpenAPI specification that we are looking at to create those resources. But we want to do this in a fully modeled way. Instead of templating this JSON blob or YAML specification and pushing it to a REST API server, we want to make sure that we use code. We use Python or Go or any other language that can be generated from the OpenAPI spec. And we want to use these native language constructs to generate our payload. And you will see why this is important and what benefits does it give as we move forward. So now we're going to create this interface. I have prepared a project. It is a Python project that we will use to kind of create the interface on our system. As you can see, it has just one basic main function. And I have created a template for my interface resource. So I want to create my interface resource. I want to put it in the namespace containerlab-vlan, and I want to name my resource my interface. So currently I do not have this interface function, so I cannot really create it. And we will type this function with you live, and you will see how IDE helps you write a 100% valid interface or resource definition without really worrying that you do not know what to type, when to type it, and so on and so forth. So we're going to create the interface, and I have created this empty function in a separate file named interface.py. And as you can see, it has nothing in its body. So we will have to figure out what we need to type to create an interface. But before we can do that, we need to generate those code bindings for the interfaces. Remember that currently what we have is just the Python program with no models whatsoever. We looked at the model in the OpenAPI format in the Swagger UI, but we do not have any Python files that generate for us the model of the interface. So let's do that. And this is one of the problems that exists within the Yang tooling. The generation of code bindings is cumbersome, and you may have some really hard issues when something does not work for your particular model. Now, this might be an issue that you cannot overcome because Yang is a bit complex, and to understand how to fix a parser or a code generator routine, you need to be more like on the software engineering side of things rather than network engineering. That is why when tooling does not work on your set of models, you are a bit on your own. As I mentioned, we will not use Yang here at all. We will use the OpenAPI specs that EDA provides to us, and we will generate pydantic classes in this particular use case. So I chose Python here because I think Python is the predominant language for network engineers outside of hyperscalers and web scalers. Now, yes, Go is taking its fair share of network engineers' attention, but still Python is probably the most used language in the network automation space. So we will use Python here, but of course, these can be repeated for Go as well, and for any other language that can generate classes out of OpenAPI specification. So what we will do is we will generate pydantic classes from the OpenAPI specification. So how do we do that? To generate pydantic classes, we will use the data model CodeGen project. So this project can generate data classes, can generate pydantic classes, and you can provide either OpenAPI spec or JSON schema and some other files to this tool. Now, what you are looking at is the command to generate the pydantic v2 classes out of the OpenAPI spec. And as you can see, I'm providing a URL of the OpenAPI spec that we just browsed in the browser using the Swagger UI. But because it's in GitHub, I can use the raw link to provide the actual JSON file that has been generated live by Swagger UI. And as you can see here, the generation is really simple. You only need to provide the output mode type, which will be the pydantic v2 in our case, and a few flags that make sure that the literals in the enums are generated. Now, 3 flags and the output directory where you want your models to be created. So let's run this. You will see a few warnings about the integer processing. as far as my understanding goes, this will not prevent you from automating this. It's just a way of transposing one format of the integer to another. So it still works. So don't worry if you see something like this. You will probably not have any issues. And maybe there is a flag that can fix that. So now we have generated the pydantic models out of the OpenAPI spec. So let's go and see what it is. Now, I specified the models directory as the output. And in my project, I can see that has been created a set of directories, COM, Nokia, EDA, interfaces. Check this out. So there is this interfaces file with a name v1 alpha 1, matching the version of the OpenAPI specification that we have been browsing just recently. And if I open this file, you will see that it has a lot of pydantic classes, right? It has the spec model, it has the breakout model. We'll see how it all used together. But what you need to understand is that with one single command, we generated the full-blown model for the interfaces custom resource that we use in EDA. Basically, like, it was a split second. And now we have our native classes in Python to work with. So let's see how we can use that. I'm going back to my interfaces.py file. This is where I will try to create an interface resource. And the first thing I will do is that I will import the pydantic classes that have been generated. Since they are in the models directory, I will just go there. And as you can see, it auto-completes just nicely. It has the interfaces module there, and the version is there as well. So I will import this as eFace shorthand. And now I have access to all the models that we have just generated. First thing I will add to my interface function is the return type. I want to be fully modeled. I want my interface function to indicate what it will return. And it needs to return a resource that is our interface. So let's see if I can use the code completion. And as you can see, as I type inter, there is already a code completion in action, which helps me to understand what can I return from the interfaces pydantic model file. So I will use the interface because I think this is exactly what the interface is. But let's see what pydantic model gives us if we just comment click on the interface. So now we back at the v1 alpha Python file that is under the interfaces directory, and we're browsing the interface class. Now you see that the interface class mimics or repeats what we have just seen in the Swagger UI. The API version that you need to provide, the kind of the resource, the metadata, and the specification field. But every field has another class that denotes what this field actually contains, like metadata. The metadata is modeled with another class metadata. The specification is modeled with the spec model class, and we can just comment click and see what the spec is. So there is this enabled flag. We have some descriptions that are fetched from the model. So everything that model had has been transformed or transpiled to a pydantic classes module. All right, so this is cool. Now let's start creating the interface. So since we know we want to create an interface resource, we type eFace interface. And now I'm lost. I do not know what to type here. I do not know what interface needs. So if I do Control space and invoke the code suggestion window, it tells me that I need to fill in API version, kind, metadata, spec. These are the fields that are available. So if I do API version, I can paste my API version resource that I happen to know to be, this is actually not correct, it needs to be like this, interfaces.com Nokia, well, this is the AI is hallucinating. So if we go back to the specification and we take this from the heading, this is exactly what the group and version needs to go into the API version field. So I paste it here. Now it looks okay. The next thing is I again use my common space code completion or code suggestion. I don't know what the actual difference, but I will fill in the kind. The kind of the resource is the kind we want to create. So we are creating the interface. So we will have the interface kind specified here. Now, as you can see, I'm typing just raw strings, and that is exactly how the interface resource is modeled. So if I hover over the API version, the type is string, so I'm typing the right things. But why is it in red? So why do we have this red error thingy? So if we hover over this, it will say arguments are missing for the parameters metadata and spec. So the pylance plugin in VS Code analyzes the class, which is the interface, and it sees that in the class there is an annotation that says that metadata and spec are required fields as well. And this gives me 100% confidence that I cannot miss something that is important. So I can definitely go and create a metadata field, and the metadata is modeled with its own class, interface metadata. Again, here, what we need to create is a couple of required resources. As you can see, it's all in red, and we have now a missing parameter name for the metadata, and we still miss spec for the resource. So now the name we will set to the name input parameter of my function, because it's here, right? So I have this name that I want my function to take in, and the namespace will equal to ns parameter that we also have in the function. All right, so the metadata is done. Now the big thing, the spec. The spec or the specification is where you actually put the configuration of your resource. Again, something that Kubernetes people are very much familiar with. In the specification goes everything that configures or defines your resource besides the metadata. So what do we put here? Like, which clause of the pydantic we need to put in the specification. So if you take a look at the hint that you get if you hover over the spec field, it says it is modeled as spec model. So if we do spec model, and again we open this up, there is a lot of stuff that you can fill in. The interface description, the enabled flag, encapsulation, everything that we've just saw in the Swagger UI is there. And of course, if you go back to Swagger and you drill down to your interface schema, you can check that this is exactly what we are working with now in the IDE. So we see that the members has this asterisk, that's a mandatory field, and the members are actually a list of configuration parameters for the link. So we need to set the interface that we want this link to have, and we need to specify the node that will be used to push this interface to. This will be the target that this interface will be created at. So let's now kind of speed this thing a bit up. So I will just start typing and will tell you a bit of the flow here. So now we're modeling, creating an interface, and we are now in the specification field. So what we will have to say, just for the sake of completeness, we will set the interface. And it's all red again now because we do not have the mandatory field members like this. So we will have to say members, and the members is a list, right? That's how I remember it. And exactly, the members is a list of type member. So I will create an empty list, and in here this is the AI doing. So eface member, and what does it say? Argument missing for parameters interface and node. So exactly, so this is gibberish. We need to provide the interface name, which is a string, right? Let me see if that's correct. We have this type hints all from the model again, so we know exactly what to fill in. So the interface name will be Ethernet 1-1, and the node will be SRL1. So I have SRL1 node in my lab, and I want to create this interface on this node. Now you see the red under striking lines are gone. That means that our resource is semantically correct. It complies with the schema. We filled in all the mandatory fields and we used the right types for all the fields. So this is how you get the confidence that your resource has been modeled correctly. Okay, now our interface is done and we return it. The type of this guy is interface, and this is exactly what we are returning. So I will save this thing. This is an import that is not there. And if we go back to my main function, now you see that if I hover over this function, it says what it returns and what it takes in as arguments. The namespace is clab-vlan and the interface is my interface. Now we have created the object right now of interface class. Now we need to make sure that we tell EDA to apply this resource. Now, of course, this is not the Python course, and I will not even show you what EDA client does. It's just a REST client. I use HTTPX as a library. I create the EDA API client, and then with EDA, there's a notion of transactions, which is a super powerful thing if you have ever tried to create a network-wide transactions yourself, and you know how hard it is to ensure that there is a transactionality in your network. We will not focus on this one because that will take another 30 minutes to dive into the transactions and how powerful they are. What we will do is that we will just use the add to transaction create function, and we will pass the my interface object to it. And then once we added this to the creation list of transaction, we will commit this transaction and we will see what happens. Okay, so now we have our terminal connections to the two lab nodes that I have managed by EDA. I have SR-Linux 1 and SR-Linux 2. What I will do now, I will create, or I will run the program that creates an interface resource in the EDA system. And as you remember, in this interface resource, we have said that our interface Ethernet 1.1 is going to be created on the node SRL1. So I want to monitor this. I want to really see what's going on. So what I will do is that I will install a watch. So I want to watch a particular command, show interface Ethernet 1.1. So now every 2 seconds, actually let's make it 1 second, interval 1. So every second the command will run and we will see the result of it. So now it says Ethernet 1.1 is down. Reason port admin disabled. There is no Ethernet 1.1 port configured on my nodes. They're empty. Now the expectation is that when I create the resource in my EDA system, it will be created on a SR-Linux 1. So what I do is I type Python main py. Now watch at the Ethernet 1.1 status at the left top pane. So now when we started the main py, we start to authenticate with EDA API server and we create the interface object. And as you can see, just like a couple seconds ago already, Ethernet 1.1 has changed its state to up. It now has the speed information and it's the output of the show command. Now, this happened very fast and it's not a speed contest, of course, but these things that EDA does with GNMI, they happen super fast. So now we have created our Ethernet 1.1 interface. As you can see, it's up and running. We have done a transactional configuration. So we first added the interface object to a transaction, then we committed the transaction. The transaction succeeded because if it wouldn't, the changes would not be applied to the SRL1 node at all. Now, this is all great, and it shows you how we created the interface using IDE, code completion, auto suggestions, type information, generated all from the OpenAPI spec. That was great and lovely. But now let's go back to the code. So what I want to do now is I want to show you that, of course, interface is just an interface. It's a very small demonstration. It is not meant to be, it will not blow the socks off of you because we created an interface. The way we created it, though, is something that is, I think, quite remarkable. Now, I wanted to show you that, of course, the transactions are meant to be holistic. You can create multiple objects together in a single transaction. And for that one, I will paste in another thing that I have created. So the banner is just the message of the day banner that we can create on a system. And again, it is modeled from the OpenAPI spec from the different application. Now I just need to import it. So I do from src banner import banner. Now my banner is created, and I can add it to the same transaction again, right? So I can add my banner to the transaction. Now I have to change the mode or the type of transaction from create to replace, because we already created the interface and we cannot create things twice. For that, we need to replace things. And I can also say replace for the my banner, because if it doesn't exist and you use replace, it will be created. So now we kind of bundling objects together in a single transaction, right? And if you go to and have a look at the banner function, it is kind of created in the same way. We have the API version, we have the kind. This is a banner class generated by CodeGen and the pydantic classes. We have the metadata and we have a specification. And here we just set the message of the day text. But the cool thing here, which is quite different from the interface resource before, is that instead of saying which node to deploy this on, we specify the node selector. Now, the node selectors, as you can imagine, is the way for us to leverage the loose coupling implemented by labels and say, I want to apply this banner to every node that to every node that has this particular label, ContainerLab equals managed. Now, my nodes have been created in ContainerLab, so they have this label by default. The expectation is that when I run this resource and commit a transaction with it, this resource will be applied to every node that has this particular label. Let's actually verify that. So now I think my function here looks all right. Now, if I go back to my terminal, and in my terminal, I will install the watch over info from system, info system banner message of the day banner. So I want to watch over this with interval 1, and I will just copy this to my SRL2. So now these two nodes are executing the info command to get the information of the message of the day banner text. As you can see, there is nothing because there is no banner configured. We'll configure it together. So now if I run the same Python main file, let's see what happens. So now we're again authenticating with the EDA API server, and then we commit in a transaction that has two objects in it. It had an interface, the previously created interface, and a banner. And as you can see, it has created those banners on two systems together, and it happened instantaneously. It happened also in the declarative manner. We did not say which nodes to tackle, which nodes to, which banner objects to put to which nodes. We used the loose coupling. We created the declarative abstracted input to the system, and EDA created the node configurations on our behalf. All right, so this is great. And I think we're quite close to a finishing sprint of this talk. So what I wanted to show now is the on-box validations. Let's go to our interface function. So this interface function, if I check what I can specify in this specification field, there is like this great MTU field. So what do I put in the MTU? Is it a string? Is it an integer? Let's see. So it says MTU variable none. So let's go to the spec model and see where it is. So we see this MTU thing, and it says it's an optional integer, and it has a field annotation that says it is greater or equal 1450 and less than 9500. So as you can imagine, this is your client-side validation. Based on this spec that we have created for this interface, we specified what are the constraints for this field, right? And if I set MTU 1500, it looks okay. So if I repeat my function, my interface should be created just like before. It will have the 1500 MTU, transaction committed, state complete, all good, no errors. But what if I do, let's say, MTU 100, and I will try to execute this stuff. Before I do that, I will set up a monitor, which is a local kind of GNMI subscription over the interface star. I want to monitor things. I will do this monitor, what is that, from running. So I want to make sure that I'm not touching my interfaces when I do this client-side validation. So now there is no communication from the nodes to this SR Linux network operating system, and I want it to be that way, because what I will do, now I will re-execute the script. And what do we see here? Validation error. One validation error for the spec model. Input should be greater than or equal to blah, blah, blah. And the input value is 100. As you can see, it happened instantaneously because we did not even reach out to the node. The node has been not touched because the validation happened on our machines based on the pydantic. So we knew that the constraints are from 1500 to 9500. We put in 100, we violated the restrictions, and the validation happened immediately. Well, okay, this was longer than I anticipated, and I hope that you find this approach quite telling. I would say it might not be applicable to everyone, but because of course not everyone will have EDA, although you should. And the reason I was showing this is to kind of provide a striking difference between the tooling that is available for non-Yang schemas and Yang schemas. As you approach Yang tooling, you might find yourself in a different position where things do not work from the get-go. Things are more complex and they are less approachable by non-experienced software engineers. Now, hopefully this will change and we will be able to enjoy the Yang tooling in the same way that I just showed you here. But it will take time. We at Nokia EDA spent a lot of time ensuring that the GNMI and Yang parts that are more complex and more sophisticated than REST and OpenAPI spec are hidden from the user, and our users interface with more software engineering based approach rather than network engineering with specific tools. Thank you for watching. I hope you will give it a try. Do remember that you can try EDA for free. It's on GitHub. You can install it on your machine, on your server, on a Mac. And the SR Linux image is free as well, so you can repeat the whole thing. I will put a link to this repository so that you can play with it as well and replicate the use cases. Do explore the OpenAPI specs and see what you can do with it. Thanks.